hope your morning so far is so good. We're going to jump into solving linear systems by elimination. And this is part one, because first we're going to just look at just adding and subtracting. And then tomorrow, well, not tomorrow, but a couple days from now, we'll look at doing it through multiplying and dividing. So if you remember, substitution's like the sexy method. Elimination's the super sexy method. Like this is like ultimate best way to do math. It's my favorite. I hope you guys like it as much as I do. So let's go ahead and jump in. Our essential question today is, how can you solve a system of linear equations by adding or subtracting? And as you notice, there's some steps. The first step is to add or subtract the equation to eliminate a variable. So remember, in substitution, we want to isolate a variable. In elimination, we're looking at eliminating the variable, so getting rid of it. Then you substitute the value into either the original equation and find the value of the eliminated variable, and then you write the source as an ordered pair. So what I like about elimination is it takes a concept like adding and subtracting, which is really easy to us, applies it to algebra, and then we just do some basic math and we're done. So let's take a look at it. If I look at example 1, I have 4x minus 2y equals 12, and then I have x plus 2y equals 8. Now, when we're adding and subtracting, the goal is, again, to eliminate a variable. So look here, you're going to want to look for variables that have the same coefficient. So x has a 4 in the first equation, but a 1 in the second equation. So even though this second equation would be easier to solve for in substitution and elimination, this is not what we want. But then if I look at negative 2y and 2y, they do have the same variable, and it works out because they are opposites, which means when I add the equations together, I'm going to get 0, right? So we're going to do that right now. We're going to go ahead and add our equations. So I'm just going to put a plus sign here to show that I'm adding. And 4x plus x is 5x. 2y plus, negative 2y plus 2y is 0. And then 8 plus 12. 8 plus 12 is 20. So now I have 5x plus 0 equals 20. But I don't really need the 0, so I'm really just looking at 5x is equal to 20. Okay, and then since 5x equals 20, I'm going to divide by 5 on both sides. And then x equals 4. So see, it's really easy actually to isolate the variable at this point. I'm going to go back and I'm going to use my drawing tool. Notice I did not use the equation tool this time, but I'm going to use my drawing tool to show that I divided. This cancels, and I added. Okay. So now you have something to kind of reference it. So yeah, what's cool is, again, you add the equations, solve for the first variable. We got the first variable x. Now we can plug it in either to the first equation or the second equation to find our y value, because remember, we need two values. We need an x value and a y value. So in this case, I'm actually going to choose the second equation, and I'm choosing the second equation because, if you can tell, x is by itself, so it's it's the bare minimum of math, and you know how lazy I can be. So let's do that. Let's do x is 4, so 4 plus 2y equals 8. Well, when I do that, I just have 4 plus 2y equals 8, right? That's the same thing. So what I'm going to do is I'm going to subtract 4 from both sides. I get 2y is equal to 4, because 8 take away 4 is 4. And then divide by 4. Y equals, divide by 2, my bad. I'm crazy over there. Divide by 2, so then y equals 2. So now I have my x value, I have my y value. I'm getting ready to make sure that I have a solution. So our solution, remember, is the x and the y coordinate together. So my answer is just going to be the point 4, 2. So can I help you find this method pretty easy? I like it. So that's how you solve it. Add them up together, solve for a variable, plug it into the other one, use a little bit of substitution, and solve for the other variable. All right, now on this one, we're doing the same thing. We got 2x plus 6y equals 6, and 2x minus y equals 8, negative 8. And again, we're looking for variables that have the sing coefficient, which in this case is the x. It has a 2 here and a 2 here. But notice that if I added the equations in this case, I would get 4x, and that's not what I want. Remember, I want it to cancel. I want to get 0. So what I'm going to do instead is I'm going to subtract the two equations. Oops. Okay. And the reason why I'm going to subtract the two equations is when I subtract it, my x's will cancel. So let's go ahead and do that. So if I subtract, oops, that's why it's looking so funky. Still got the rectangle tool. All right. So I know right off the bat, if I subtract 2x from 2x, it's going to cancel. So now I'm just going to look at this negative 6y minus negative y. Now be careful when you're subtracting. It's not going to be just 6y minus y to get 5y. It's going to be 6y minus negative y, which remember those two negatives make a positive. So then I'm going to have 7y. So 7y equals, actually we'll do a different color on this one so you can see that it's different. 7y equals, and then now again I have 6 minus negative 8. And so 6 minus negative 8 is the same thing as 6 plus 8, which is 14. 7y equals 14. Divide both sides by 7. Y equals 2. Now that I have y equals 2, I'm going to plug it into an equation and solve for the other variable. This one, again, I'm going to choose that second equation because it's just got y by itself. So let's go ahead and do that. We'll actually do it. Oh, I guess we'll use the equation tool. That's messing up our font. All right, so I'm going to have 2x. I'm the original equation, so I'm not using that negative, including that negative, I guess. So just be aware of that. So 2x minus 2 equals negative 8. Okay, and then I'm going to add 2 to both sides. It's a two-step equation. When I add 2, it cancels. So then I have 2x equals 8. If I divide by 2, I'm not gonna bother with the division, but if I divide by 2, you should understand how I'm gonna get x equals 4. I'm just being lazy. So then our x value is 4. So now I have my x value, I have my y value. So my solution is the point 4, 2. Remember, x before y. Sometimes just be careful because I know, I mean, you guys are probably better than me no matter what. But sometimes I know I will just put the first number first. So if I found 2 first, I would put 2 first and then x for second because I found x second. You got to be careful. You do want to make sure that you are putting the x and the y in the same spot. Well, okay, we actually got the same answer that time. That's kind of cool, right? All right, last example. I have negative 4x minus 2y equals 4, and 4x plus 2y equals negative 4. So again, on this one, it looks like adding is going to be the best strategy because if I add, I know my x's are going to cancel. But previewing it, if I add, I also know my y's are going to cancel. So let's see what happens. Let's try this out. Oops, what happened? So I'm going to add my equations. Well, x cancels, y cancels, and actually 4 take away 4 cancels too. It gets 0. So remember, everything canceling doesn't mean that it's just gone. We do have a numerical value left. We're going to have 0 equals 0. So if you remember on our last notes, we looked at substitution and we had a bunch of vocabulary, what substitution, what different solutions look like when we're using substitution algebraically or solving systems algebraically. And the same rules apply for elimination. And so if 0 equals 0, well, this is a true statement. 0 is 0. So then all I have to say now, if you remember, if it's a true statement, is that it has infinite solutions. And then I'm done. So that's really easy about elimination. Is actually, this is like the bare minimum amount. You just add them together. The equations cancel, you get infinite solutions. Alrighty. Try thinking about answering the essential question, and that's all I got for you today.